Hello, everyone. Thanks for coming to the first in a series of 6 public lectures in the Leading Voices series, which is also part of a undergraduate class here at Dartmouth. I believe this is the 3rd year in which the Leading Voices series and course is being taught. And it is my pleasure to introduce Elizabeth Wilson as the first speaker in this series. And just to remind everyone that this is going to be taking place every Thursday at 4, basically in the same time, same place, for the next 5 weeks. And if you're interested in looking to see who are the next speakers in the series, you can basically go to the Dartmouth website, put in Leading Voices, and you'll find the information on who's speaking next week and every week after that. And to just introduce Elizabeth Wilson a bit, she originally hails, I've learned, from California. Did her undergrad at Santa Cruz, that's right, and got her PhD at Carnegie Mellon in engineering and public policy, then spent some time at the EPA, and now it works at the Humphrey School of Public Affairs at the University of Minnesota, where she is a professor and expert in energy and environmental policy. I believe today she's going to talk to us a bit about electricity and wind and all good things. So without further ado, Elizabeth Wilson.
I'm really pleased to be here today. And one of the things I'm really excited to talk about is a creation of kind of a new socio-technical system. If you care about climate, if you care about energy, you care about electricity. For the first time in years, last week we had President Obama's climate talk. And I think it's just important to recognize that globally, the electricity system is responsible for about 41% of all CO2 emissions, 26% of all greenhouse gas emissions, and that while electricity generation and growth in this country is relatively flat, globally, over the next 20 years, it's projected to grow by 70%. So this is a conversation that we're going to be having today about the creation of wind in the United States. But I'm happy to take questions, and I'm happy to talk further about global implications and global wind development as well. So when we talk about wind, oftentimes we talk about the specific technology, but really what we're talking about are wind connected to transmission grids embedded in very complex socio-technical systems. And the systems that we use to create and develop wind are evolving today. And so in this talk, I'm going to go through a very simple kind of 3 focal areas or 3-step program. The first is to build wind turbines, and we'll talk about the different policies, the different politics of building wind turbines in the United States. We'll then talk about connecting wind to the grid, because of course the technology only works if it's connected to the electricity grid and actually delivering the kilowatt hours to customers. And finally, the challenges of integrating wind into our electricity markets, planning for new transmission, and these larger questions then that are affecting today turbine design and deployment. Now, for the first focus area, we'll be looking at building wind, and many of you are familiar with the map that I'll show next from the National Renewable Energy Laboratory that shows the best wind resources in the United States. The purple areas are the best, followed by many of the other areas. And you can see, of course, that the center of the country having the best wind resources. And what's economically available to develop is pretty much anything above this kind of brownish color up. So that's what's today economical to develop as a wind turbine. And so one thing that my colleagues and I'm going to be talking today about some work that I've done with Jenny Stevens at Clark and Harvard and Tarla Ray Peterson at Texas A&M, is we noticed that, from an engineer's perspective, you build the wind where the best resources were. But that wasn't how wind actually developed in this country. What we saw instead was the technology developing like a bad rash And what we did here was we looked at, we used FAA data to map these first wind turbines. And you saw it happening in states not where the best resources were, but where you had state-level policies or state-level politics that were promoting the development of wind turbines. And for our study, this was our first National Science Foundation study, we looked at 4 states. And we looked at states with a lot of wind and no wind. And we looked at states with a climate policy driver and no climate policy driver. So that was our kind of experimental design of trying to understand a state like Texas, which has high wind deployment. Actually, today it's the largest in the country, but not really a strong environmental or climate push. And contrast that with a state like Massachusetts, which has a very strong climate policy, lots of beautiful language about building renewables and creating low carbon, but actually very low deployment of wind and renewable technologies, even though the policy environment, the political rationale is quite strong. And so I just want to contrast this map that's a few years old with where wind is end of 2012, where we now have about 60 gigawatts, 60,000 megawatts of wind. Each turbine is about 1.5 to 2 megawatts, so to give you some idea now how many they are. And giving you also this picture to kind of show you where most of the wind is located in the US. And I'd like to point out our 4 study states. Today in Texas, the largest state by a factor of more than 2, they have about 12 gigawatts or 12,000 megawatts of wind. Up in Minnesota, we have almost 3,000 megawatts of wind. In Montana, my state with no climate policy and no wind, there's about 645. And then in little Massachusetts, they have 100, which is the size of a small wind farm in Texas, is about 100 megawatts. So just to, again, I'm surprised that even today, kind of our study design across these particular states actually holds true many years later. So the other piece I think that's interesting that I just want to point out here is not only do you have different levels of deployment, what we also found when we analyzed the projects was the size of wind operations was very, very different. And the size of the wind operation in Texas compared to Minnesota was usually about 3 or 4 times as big. You had about 3 big companies in Texas that owned 50% of the wind, whereas in Minnesota we had much smaller projects with many more diversified owners groups. And so the politics of who supports wind, who benefits from wind, are also quite different in these jurisdictions. And the reason why I'm showing you this is to highlight some of the very different and what I think important jurisdictional differences in both creating energy policy and then developing the socio-technical systems and how they're shaped across our different jurisdictional boundaries. As many of you know, most of the key decisions to build and approve energy infrastructure projects happen at the state level. It's your public utility commission, your public service commission that allows these projects to be built. And so what we are interested in here is trying to understand how different socio-technical factors are shaping wind development across different states in kind of building turbines at the beginning. And so the study design that we had for this entire study, I'll just walk you through it quickly, was we were looking at 2 technologies. We were looking at wind and a technology called carbon capture and sequestration. And we had 3 methods. We were looking at policy and document analysis. We were interviewing energy policy stakeholders, and we were analyzing public media in each of our different states. And for this analysis, as I mentioned before, we had 4 states: Massachusetts, Minnesota, Montana, and to vary up our M mix, Texas. And then our kind of theoretical framing for this, we were looking at state policy diffusion coming from political science, but trying to look at it within a natural resources framework. because there had been a lot of work in the policy world that said, oh, you know, policies go from one state to this other, this idea of states as laboratories for democracy, that famous Justice Brandeis term, where we experiment in states and other states adopt. But there hadn't been any real linking this to, do the states have wind or not? So thinking about especially resources like wind, like solar, like CCS, within a natural resources framework. And then this idea of understanding how the different stakeholders who are involved in creating the energy system perceive both the benefits and the risks of the different technologies. Now, there had been a lot of work that had been done asking lay people like ourselves, you know, what do you think about wind turbines? And people would say, they're good, or I like them, or I don't like them. But we decided for this study that we were really going to focus on the people that make energy policy. So if you testified in front of the state legislature in Minnesota, Montana, Texas, or Massachusetts, we tracked you down and we interviewed you. And so I'll tell you more about that in just a second. But for this talk today, I'm going to focus on wind power. I'm going to talk to you about the interviews that we did with energy policy stakeholders, and I'll focus in the talk on Minnesota and Texas. I have all the rest of the data as well if you want to talk about the other technologies or the other methods that we can talk about later in the question and answer period. So here's how wind kind of happened in Texas, where we had policies that were enacted. The renewable portfolio standard that says, you know, Texas should build 5,000 megawatts officially began. It was expanded here. But the important one I want you to look at is also here on the bottom. Federally, we have a policy called the production tax credit. For every megawatt hour I pay you, every kilowatt hour I pay you 2.1 cents. So it expired here. Next year, no wind was built. It expired here. Next year, no wind was built. It expired here. Next year, no wind was built. It's actually been continual, and I'll show you more recent numbers. But we saw this kind of interplay between state build of wind and federal build of wind in all of our different states. We have Massachusetts at the top. Notice the axis that I think stops at this point at 6. We have Minnesota here, which is stopping at about 1,500, Texas. But again, this stop-start mechanism of federal policy really affecting the investment and deployment of wind turbines across the country. Here's a graph that I just pulled from the American Wind Energy Association, where you can again see the different add-ons here. And so what they highlighted here were the annual capacity installations in this dark blue color. And so you see those years when it expired, when it kind of dropped off a cliff. So this is today, 2013 in the country, 60,000 megawatts of wind. And this ramp up has been actually quite incredible. As many of you know, the production tax credit was set to expire last December 31st. And what it gives you is for the first 10 years of your plant operation, that benefit, that extra 2.2 cents per kilowatt hour generated. Look at the installation in the fourth quarter of 2012. Everybody was out in the field trying to get their turbines in as fast as they could, but new jobs were actually stalled. And so you saw this huge push at the end of last year. And this last quarter, you had the kind of largest capacity addition ever. It went about 10,000 megawatts, boom, within a quarter. So again, how the investment cycle also responds to these federal policy initiatives is really interesting to think about too, in this interplay between politics. But I told you I was going to be talking about my energy experts. We ended up talking to 84 policy stakeholders across our 4 different states. These came from industry and NGOs, government, environmental NGOs, as well as a few academics. As I mentioned before, these people had testified in energy bills. We considered them kind of the energy elite within their states, and then we would ask them also, who else should we talk to if we want to understand the issue? And we would snowball sample that way. So that's how we developed our sample size. And from that perspective, we had all of the interviews transcribed and then coded them based on a framework where we were looking for aesthetic and cultural, economic, environmental, health and safety, political, or technical frames. And we were looking for kind of positive, are these facilitators, or negatives, are these barriers for developing wind systems? So trying to understand in each state, what are they saying, how are they talking about wind? So for example, a positive facilitator would be a market is available for the technology. A negative would be technology is not developed for commercial scale, just as an example. So we were looking at this across our different areas. And one of the things that we found that was actually quite interesting is, while the media coverage tended to be a little bit more skewed sometimes, the expert discussions were actually pretty balanced between positive and negative attributes. But they were focused on three things. What the experts were caring about were the technical aspects of wind. They were the political aspects of wind, and this makes sense because we're talking to policymakers, as well as the economic aspects of building wind systems. So that was who they were caring about. Interestingly, environmental aspects, health aspects, aesthetic aspects were really not a big part of the conversation, although in the public literature especially, a lot more of the aesthetic and kind of cultural impacts of wind came up in our media analysis. But when you talk to the experts, this is essentially what they were talking about. And one of the things that, just to give you some idea, if we're talking about, the technical frame, as we mentioned, it was very balanced. When they talked about it, the positives were that wind energy was seen as having a very promising resource with a lot of promise. The negative issues that came up again and again were issues of transmission issues, as well as the variability of wind and how do we integrate this into our electricity system. One of the things we appreciated as well was that when we started looking at the quality, what these people were saying, what they were talking about really differed from state to state. Now at this time, as you know, Texas already had a lot of wind. And February 2008, they had an event where the wind went from like 1,100 megawatts to 300 in the series of just a few minutes. And they lost a lot of that load, and their system ended up having some big problems. So they were talking already about the effects of how do we manage large amounts of wind on the system. Whereas in Massachusetts, stakeholders were generally positive in principle. They liked the idea of wind, but they didn't have that same direct experience. Interestingly, Montana also talked about wind and some of the negative aspects, but they didn't really have much experience with it either. In all states, the economic frame incorporates the financial aspects, including costs, relative to other energy sources. When stakeholders who are involved in transitioning grid, they don't talk about just one technology, they talk about the system. And so it was really wind in relation to this. They also spent a lot of time talking about the potential for green jobs and economic rural development, as well as revenue generation for local communities. And here's actually something that's kind of interesting, and I'll talk about this a little bit more later. But Texas, interestingly, had twice as many positive references as negative references in the technical and economic category, in part because of some of the system attributes that I'll talk about in just a second. So we talked about all of these. In Minnesota at this time, the state had just passed a renewable portfolio standard and really saw itself as a leader in promoting renewable energy and in promoting wind in particular. And wind was really framed as a community development tool. There had been legislation that passed to facilitate what we called community-owned wind. If I'm a big company and I put a wind turbine on your land, I will pay you $3,000 to $5,000 for the privilege of each year as a lease payment for my turbine. If you were to own that turbine, you would earn roughly $25,000 a year. So there were a lot of efforts to ensure that local landowners would be able to own their own turbines or own them in smaller quantities. The pushback that was coming on transmission lines, how many of you have heard or remember Paul Wellstone? So Paul Wellstone actually got his start in rural Minnesota organizing people against transmission lines. So there's a good and illustrious history in Minnesota for transmission lines. So this was a really interesting shift. So that was the one pushback there. But one of the quotes I have from one of our legislators was, "Climate change has really driven the market for wind power." There was a clear linkage to the environmental attributes of wind to climate change. Now, I just want to contrast that with Texas. Again, they had lots of wind already on the grid, and they were really focused on steps to ensure its future development. The legislature was busy defining renewable energy zones across the state and doing transmission planning to link this wind. Texas had about 17% of its wind curtailed because of lack of transmission power. And so this was a discussion that was really important there. But wind and renewable energy policy are framed almost solely as economic development, and the environmental benefits are not really mentioned. The other thing about Texas that I think is really interesting was that Texas' electricity system is one where natural gas was on the margin. And natural gas during this 2007 to 2009 timeframe was very expensive. And so wind really was the low-cost option. So here's one of the quotes. "Wind typically displaces natural gas generation. As natural gas prices have gone up and stayed high, the cost of generating electricity with natural gas is basically what wind is competing with, so it competes very favorably." So that economic framing was very effective. And one of our stakeholders said, stakeholders don't talk about climate change when they go over to the Capitol. They talk about economic development. This was a really important piece. And one of my favorite quotes from Texas, "It's politically difficult for a legislator to stand arm in arm with the environmental community, regardless of how good the idea is." And so that's a problem perception. Alternative energy, renewable energy, wind energy, solar power have the perception of being things advocated by tree huggers, with beads, wacko liberal type folks. And so there's a perception, that's just a knee-jerk perception among some legislators, that anything that some of these folks may have to say is just rejectable out of hand. So this is a very different environment than what we saw in our other states, and the political ramifications and how you would argue more wind in Texas wouldn't be bringing Natural Resources Defense Council to your meetings, right? You would bring T. Boone Pickens, which is what happened. So our next focus is on connecting wind. We've spent a lot of effort, a lot of policies developing wind. And one of the things that happened relatively quickly was this next challenge. Well, wind plants can really be built within a year. Transmission takes 3 to 10 years to actually plan and build. The Lawrence Berkeley National Lab market report talked about how 17% of wind was curtailed in Texas one year because of transmission constraints. That means the wind is not getting to market. That means you're not getting the money for producing it, depending on how your contract is written. In the upper Midwest, I think we had about 4.5% due to congestion from transmission lines. And nationwide, this is curtailing about 1,000 gigawatts of wind just because of transmission shortages. So this is work that I've done with my colleague at Minnesota Law School, Alex Klass. And we started doing this work in part because of our conversations with our different energy stakeholders. And it's important, I guess, to realize that when we're thinking about the US electric grid, we're actually thinking about 3 grids. We have the Eastern interconnection, the Western interconnection, and then the Texas interconnection. Does anyone know why Texas is separate? So Texas is separate because if you are connected to other states, you're under then the jurisdiction of the Federal Energy Regulatory Commission. But because Texas is not connected, FERC has no power over them. So it's a when they break off, they'll be, it's what? Yeah. So So the other piece that's important to remember is while these transmission lines, high voltage, this is the high voltage transmission system. These aren't the lines going to your house. These are the high voltage transmission lines that take power and move it across long distances. But it's important to remember that these projects, while they may be interstate, are approved by our state public utilities commissions, public service commissions. In the class that I lectured in earlier, the readings that you had talked about this line coming down from Canada to New Hampshire. What is it called? The Northern Pass Line. So again, this would have to be approved eventually by the state. So this is a map that we published in Energy Policy. It just came out, where it shows where the wind is and where the transmission lines are. The dotted lines are kind of the new planned lines. So a lot of the wind in Texas, you'll notice right here, that was financed by this, the CREZ lines, the Renewable Energy Zone lines that they built, that was started by the legislature and built, is actually now providing power to many of the fracking operations. And some of the politicians are really happy for this political cover, because they can say this is now helping other sectors and jobs develop. If it was just wind, they risk being tarred as environmentalists. So there's an organization. How many people here have heard of regional transmission organizations? Great, great, great. These are organizations that are kind of subsidiaries of the Federal Energy Regulatory Commission. And they serve two main functions. The first function is to plan future electricity systems across the different footprints. So here we have MISO, which is the Midwest Independent System Operator. Right now we're sitting here in ISO New England, the system operator for New England. And they also have another really important function, which is to operate wholesale electricity markets, the bulk power electricity markets. So these organizations are doing two very important things. They're voluntary organizations, but FERC strongly encourages all utilities to join. We're going to come back to this in a minute. But when we talk to the engineers, remember before we had the map of where we should put the wind and engineers would put it where the best resources are? This is an engineering vision of what the future power grid could look like. This coast-to-coast super grid overlay. This was actually put out by American Electric Power as one of their kind of discussion lines. Here in red are the existing 765 kV lines, but their plan is to kind of grid the country, and that would allow for more efficient electricity markets and interties. Politically, how you would develop this remains a mystery to me, but from an engineering perspective, it's quite beautiful. So again, tempering our expectations with a less beautiful reality, we will start here with the MISO MVP, or multi-value project portfolio. And in the upper Midwest, the Midwest Governors Association and MISO worked together for the first time ever in a process much like Texas is, to define renewable energy zones where the areas were most likely to develop renewable energy across the MISO footprint, and then run a couple of different scenarios. One was looking at the existing policy commitments. A lot of our states have renewable portfolio standards, like Minnesota, like many of the other Midwest states. What if we just built the 25 gigawatts of wind, about double what we have today? What would our transmission infrastructure need to look like? And then they ran another scenario. They ran a scenario that said, what if we went large-scale wind and had 30% of our power come from wind energy, which we could potentially do? And this was the Midwest Governors Association working together, all of their staffs, through this kind of big multi-state process. And what they came up with were two very different plans of what our transmission infrastructure needs to be. And they said, well, actually, we can't decide whether or not we should build this or this right now. It's just too hard of a decision. So we'll build what we're calling the no regrets lines. And that's the 17 lines you see on this board right here. And these lines, building these 17 lines, costs roughly $5.5 billion. So that's the other thing to remember about energy infrastructure, is it's really expensive. And it's the first time that an RTO has approved this level of lines, this level of investment to be shared, the cost to be shared across the entire footprint. All customers in this are going to pay for it, not just state by state, but it's going to be shared as a postage stamp. People used to call it socializing the costs. I was down in Texas and they say we call it uplifting, which I thought was a surgical procedure, but that's because I'm from LA. So these lines are going forward. They were approved by MISO, and there was actually just a 7th Circuit Court decision because Michigan had to sue. But that says that they have proven benefit to the system, and these lines are now going approved to be built. That said, they still have to be approved by every Public Utility Commission and get cited. That's another issue. But for the first time now, we're talking about the integrated transmission planning. That's an important piece of this. So the last step, integrating wind. How do you integrate a large-scale variable resource into our electricity system? What are some of the steps? In the past, when wind was small, no one really cared. When wind was small, it would produce electricity and come onto the system. But we have states now like Iowa, where wind is about 25% of their production. And it comes on, and sometimes it goes off. How do you incorporate a variable resource like this? One important technology is forecasting. And now wind forecasts, there's a lot of effort going into forecasting wind and generators built in. But an experiment that's been happening in Texas and in MISO is now we are doing something called dispatchable intermittent renewables. And we're allowing wind to bid into the market like any other generating resource. And one of the reasons that rules matter is because how wind is allowed to participate in the market, what it gets credit for, actually affects the bottom line and the value of this resource. With some of my students, we did an analysis of a pumped hydro energy facility or storage facility. Do you know what that is? You pump the water up when electricity prices are low, and when electricity prices are high, you run the water down and it produces electricity by running it through a turbine. So it doesn't produce electricity, it really stores energy and then sells it at a time when it's higher. And so when we analyze the value of this technology, 40% of the value of the technology came not from producing kilowatt hours, but actually producing something in the market called ancillary services, regulation services, voltage regulation services, load following services. These are other market products that you have to make the system work better. So 40% of the value came from that. And that was under MISO rules. When we took ISO New England rules and said, what if it looked like this? The value of the production facility went up 250% because of how they value ramping under ISO New England rules. So these rules actually can have a material effect on your bottom line and how much your technology is worth. So in the dispatchable intermittent renewables program, wind bids into the day-ahead market. Here's MISO again. Wind bids into the day-ahead market, and then it's very hard to predict the wind. You can get a general idea, but actually, you have to produce within a band of how much you said you're going to do. And doing that 24 hours in advance is really quite hard. So what MISO allows the wind operator to do is true up its projection 15 to 10 to 5 minutes before dispatch. And this truing up, wind actually is very persistent in the short term. So if you produce this much last minute, chances are it's going to be close to that the next minute, just because of the way the systems work. And so through this truing up, they're actually able to have wind bid in. And now, as of 2013 March, all generators that were built after 2004, which is most of them, participate in this dispatchable intermittent renewable market. And what I think is interesting is that I'm on a project now that's working with a bunch of people that design not wind turbines, but wind farms. NREL, the National Renewable Energies Laboratory, has estimated that wind farms lose 20 to 30% of the potential power they could produce just through interactions of the different turbines. And so they're looking at ways now to operate the farms to better participate and maximize that power. And one of my favorite projects right now involves control systems engineers and aerospace engineering and electrical engineers and economists, where we're talking about, how wind could be controlled to actually provide these other ancillary market services or other attributes as well. And before I met the control system engineer, I always thought of a turbine as a fixed object. And he said, no, there's the hardware part. It's like, but I do software. If I want to change that software every day, I can. And this idea that they can make the blades feather differentially depending on the conditions. They can potentially just do some more advanced controls to potentially provide these other market services. So the piece that I want to bring back here is actually what I've told you is not a three-step program, but really a four-step program, right? Where we build wind, we connect wind, we integrate wind, but now we evolve and repeat. Now we're changing how we design the turbines. We're changing how we design the control systems to be able to make wind fit. And what fits in the upper Midwest, where our constraints are, is different than Texas. It's different than what you have up here. And so you're really seeing this tailored wind and these tailored types of technologies that are being developed today, which again brings us to another place. So my ongoing research right now is looking at smart grid as well, and we're doing some other work on post-superstorm Sandy with the wind piece and the integration piece as one of those steps. But I think the really interesting piece for me is this creation of a socio-technical system that may start with a policy and a technology, but quickly evolves into how we train our students, how our markets operate, how the technology happens, and thinking about how the regimes and landscape are shifting to promote or support or thwart additional wind resources. So I know here in this part of the country, public acceptance has been a huge issue for turbines, and we've seen some of that as well. But this idea that this wind transmission and integration are requiring us all to create a new language for thinking about these systems and really different incentives, challenges, and opportunities that they're providing for us all. So the other piece that for me has been just fascinating in this research is the very different socio-political context that exists across different parts of our country. When we're talking about wind in Montana, it was all about transmission lines. And they weren't so sure. They wanted transmission lines shipping the wind out of state just so California could drink green lattes. Right? I mean, it was politically framed in that way. But that stakeholder perception and framing are driven both by their industrial base and the existing energy system, but also the level of maturity of technology deployment within that system. And so we're really seeing this kind of evolving system. The other piece that we realized was that Texans talk 20% more than other peoples. I have the data. We recorded all the interviews. We actually did our transcription budget based on Minnesotans and people from Massachusetts. That was bad. So they blew our budget. And this isn't work that I do alone. This is work that I do with colleagues and a wonderful team of students at Minnesota. And I'm just thankful for having colleagues across campus as well as my colleagues at Clark and Texas A&M. So with that, I'm happy to take any questions and have a discussion. Thank you very much. So, yeah.
A couple of questions. One, on the connection, number 2, is there any talk about superconducting trunk lines across the country, for instance, from the Midwest or the West to New England, and so on and so forth?
So actually, I mentioned to you the regional transmission organizations, the RTOs. Yeah. Some of the people that are most opposed to that would be ISO New England. I mean, I don't know if you realize it, but you guys pay about twice what we do in electricity. Sorry. And all of the documents talk about, basically if you bring in cheap power from the Midwest, you undercut every utility's investment. You basically take your whole system and kind of shake it up. So in some ways, these RTOs now are acting as kind of balkanized states in their interest. Right. And so the arguments given in the documents for ISO New England are that you care about climate, and if you took a power line from the Midwest, you would also be taking our dirty coal. So there is, the engineers talk about this beautiful super trunk line. I showed them to you before. But politically, who pays for it, who benefits from it, is very, very touchy. If it goes through a state, but the state doesn't get any power from it, should that state actually have to pay for that portion of the line? Again, this cost allocation question is blood sport.
Yeah, but that answer is a little bit like saying the public doesn't talk about climate change, so therefore let's not worry about it. Because climate change is really driving this whole thing, except nobody wants to talk about it.
Especially in Texas.
Political to talk about it. But in fact, this was my next question.
Yeah. Well, can I answer that first, though? Because sure. I think it's actually a little bit more complex than that. Climate change is one of the rationale for a set of actors, yes. But there are other people who are making money selling turbines or who are making money doing wind prediction systems that may care about climate, but that isn't their bottom line. Their bottom line is selling 60,000 turbines in the United States.
Sure, I don't argue with that.
And so, yeah, okay, your next question.
The next question is, eventually, because of the crisis of global warming, we're going to need to reduce our carbon output in the atmosphere to 0 or close to it. That means renewable energy. And if we do that with wind and solar, primarily, are there advanced storage systems that are in the works that you know about, not to go into production today, but that can handle large amounts of storage over time to take this intermittent, even well-managed intermittent power and keep it continuous?
So this is a good question. And the question of large-scale deployment of renewables, there's some reports that were done by the Department of Energy. The National Renewable Energy Lab that I mentioned before has done one on 20% wind penetration. What if wind produced 20% of all of our electrons? There have been other studies in the upper Midwest that have looked at higher numbers, like 30%. And I want to answer this in 2 parts. The first is, in this country, we're actually quite good at talking about generation. I can give you emission factors and production rates of every power plant in the country on an hourly basis. I can look at market clearing prices for electricity on the 5-minute level. I can tell you what it costs at every 5 minute at a bunch of different locational marginal price nodes across my systems. The last time we did a commercial building energy survey in this country was 2003. Where we surveyed 8,000 buildings nationwide. Okay, we have the supply conversation, I'm guilty of it too, all the time. The demand piece and shifting demand and managing demand isn't something we do that well. We spend $7 billion a year on energy efficiency programs, no evaluation on looking at the consumption data nationally. Okay, so there are pieces of this. We talk about it from a supply angle and the need to back up the storage. I think we also need to be having this conversation on a demand side. In the electricity system, we were talking about it earlier, it's not as complicated as chess, but it's a little more complicated than checkers. You have 3 moves. You can produce, you can reduce, and you can shift. And so with storage, you shift. And there are other ways to shift as well. You can shift by shifting demand. But back to your question about storage technologies, yes. There are storage technologies that are under development. We have actually globally, I think about 126 gigawatts of pumped hydro energy storage. There was a company, Beacon Power, which was looking at flywheels that just went out of business outside in Massachusetts. And then there are, of course, the battery storage technology options, which remain very expensive. I mean, the question is cost. And currently, we prioritize low-cost electricity, and we haven't needed it this way. You know, storage in some ways is the flip side of transmission. You can either have a lot of transmission and non-correlated wind resources, or you can have less variability or more variability and storage. So it's really interesting, and the question I think varies across scales. Yeah. Thank you. Yes, sir.
What information is available on the differences in production cost of wind on a state-by-state basis and the contributions of regulatory complexity and transmission to those projected costs? And are there benchmark comparisons with fossil fuel production costs on a state-by-state basis?
So the reports that I would send you to, I can think of 3. One that you will really like, and it comes out every year, is the wind market report from Lawrence Berkeley National Lab, where they give you a really wonderful review of kind of the last year in wind, where those issues are, where the transmission constraints are. The second one, in comparing with other energy sources, a lot of Department of Energy reports do this and look at the cost of production. Although I'll argue with you a little bit on this, because I think that cost of production, especially for wind, varies so considerably given and actually the LBNL, the Lawrence Berkeley National Lab market report has this, but it varies according to the wind profile, it varies according to what market you're bidding into. There's actually a place, let me find this on the map, this is so cool. There's a project in Utah. Yeah. Here in Utah, this project is actually, it has a high voltage transmission line to the Rocky Mountain electrical plant, and then it has a 500 kV direct current DC line that goes from Utah all the way to California. So while it's located in Utah, it's electrically California. So it sells into that really high value California electric grid. So even when we look at the states and where you have the policy, and the guy who actually helped develop the project, it's a company based here. I was told it's called First Wind. I was told if I wear the t-shirt in Vermont, I might get harassed. I was going to bring it to you guys as a gift, but I forgot it, I'm sorry. But he lives in Minnesota, and he talked about developing this project was this incredible political balancing act. Because California has a renewable portfolio standard that requires them to have 33% of their generation come from renewables. But as many of you know, building things in California is almost as hard as building things up here. And there was this real, but LA and the LA DWP, Department of Water and Power, was one of the worst offenders. They had this big coal plant and they needed renewables. They were getting a lot of pressure from the state. And the mayor really wanted to leave some kind of legacy as he was stepping out of office. So he's negotiating with the unions. Will you allow this electricity to come out of state that's not union? In Utah, they liked the idea of the local jobs that this would provide, but no way did they want to be seen supporting wind energy. They said, well, you know, Utah's a state that tried to legislate against climate change. Right? The legislature almost passed a law saying climate change was illegal, to talk about it. so they said, you know, you can build this, but don't expect us to use the electrons. So it was again, you know, showing like the politics that happened to build these projects. So when you look at this project, you say, why does Utah have this wind? They don't have, we'll look back at the map. Numbers that one. They don't have that great of wind resources. The projects right here where they're a little bit better. But it was because of the ability to sell from low-priced Utah markets into high-value California markets through the transmission grid.
What does Nevada think of all that?
The line was already there. The line was already there. The line is actually taking power from the big Rocky Mountain Energy Power Plant out, which was one of the biggest coal plants in the West that is now actually being changed to natural gas because of the cheap gas prices. I'm going to take one in the back and then one over here. Yeah, ma'am.
I'm not convinced about the economics on this, I guess. The graphs you showed initially showed that the only incentives were when they were government subsidies to build wind. And then you discussed data when natural gas prices were high.
In Texas, because gas was on the margin.
Right.
That wasn't the case in Minnesota.
Natural gas prices are not high.
So now the situation has completely changed.
Exactly. So I guess I'm concerned that with the much greater footprint you need for a wind farm, and the capital costs, and the fact that you still need to build the same size carbon backup plant if the wind dies, presumably, if we don't figure out kind of how you deal with the variability factor. There's a lot of investment going in.
I think obviously we have been dealing with the variability, though.
Okay, does it?
That's what the part about integrating wind was all about how we're handling.
I understand, but economically, have we gotten to the point yet where that means we're either building fewer fossil fuel plants, or they're operating less, or that we are going to build smaller ones in the future? I guess that's my question.
So your question is a total system question. How will it develop?
Right, and obviously there are other considerations behind economics, but my bigger question is, obviously, if you consider the environmental concerns and you take that into consideration and assign an economic value to that, that can be taken into consideration as well. My bigger concern goes back to one of the very first comments you made, which is globally, the increase in electricity demand is not coming from the United States. It's coming from China, from India, from Africa, from Brazil, from places where the population is growing and the standard of living is rising, and they are not concerned at the moment, or at least not building, alternative energy resources. So are we putting ourselves at an economic disadvantage internationally by doing this, and how do we work with other countries then to either convince them of or bring them along, both to level the playing field for ourselves, but also then to reduce the carbon that's being emitted?
I mean, this is the holy grail.
Could you maybe paraphrase?
Yeah, I was going to say, it sounds like you guys want me to come back next week. I mean, this is the holy grail. I mean, what you just put forward is how do we act locally and change our existing system while keeping cognizant of the global trends and larger forces affecting carbon and environmental development everywhere. I mean, how do we hold these two need to change what we do and be cognizant of things we have no control over, really, at one time and place. In 2009, 2010, I spent the year at Tsinghua University in Beijing. And what was really interesting to me, and I told the class this already, was every time someone showed something on carbon, you know, here we show a slide and it will say China is the largest emitter of CO2 followed by the US. Right? This is common. I've given this talk before too. Every time they talked about this in China, they would say the US per capita produces 5 times the greenhouse gases of China. Now, just that different display of data has a really different moral valence as to what your policy options and solutions could, should, or would be. So I think this is really tough. And in China right now, I mean, they're building 25 nuclear plants a day, and they've committed to build 20. So just roughly, our electricity system is roughly 1,000 gigawatts, a round number. It's a little bit less than that, but 1,000 gigawatts. China's roughly the same size, a little bit smaller, but roughly the same. They have committed to build 100 gigawatts of nuclear, 100 gigawatts of wind, 50 gigawatts of solar. And when you look at the projections, 1,000 gigawatts of new coal. I mean, these are hard truths that are coming together. But with your I felt like your characterization of wind in this country, I mean, I think it's important to recognize that where the wind is really changes the economics, and that the goal now is how do you produce the most power using the least amount of land with the least social impact. And the idea of being able to fine-tune these wind farms to actually make more power on a smaller footprint, or potentially even have them work in ways that are more socially acceptable. If there's flicker certain times of day, if there's bird migrations, can we curtail the wind for those other societal values and purposes? But in China, I mean, if we keep using per capita, you know, and the other class saw the slide of kind of, you know, US consumption per capita, we're one of the highest energy users in the world. And so, you know, dealing with our home system here is actually something we can and need to control. And I would argue that we have more influence and more experience to help others develop systems if we do it here too. And I fully see all the students that you see up front here, you know, engaged in this for probably, it's enough work for several careers. But this is really important stuff, and you raised huge questions. So, yeah, so. Oh, I'm sorry, 1, 2. I'll take, actually, we're running a little bit out of time. How about I take both of your questions, and then I'll answer them both together. And if anyone else, we can do a couple together, I'll note them down.
You talked about wind in the, on land. How about wind offshore?
Okay, so that's one. What about you, sir?
Yeah, I wanted to ask a little bit about what your guess is, what the future is going to be like, particularly in terms of the changing variables of production type credits, and gas prices.
I think gas prices is a huge one. And then anyone else have a question? I'll just throw it in. Yeah.
I know out west there's like a big demand for people to work on wind turbines, and I was wondering if there's any limiting factors, like not enough people knowing how to repair them and such for building more.
Okay. Yeah.
I'm just wondering if you were to consolidate wind turbines in the central area of the country where the wind is most dominant, if it would be feasible to then transmit that electricity to the rest of the country, or if it would be too costly and you would lose too much of the electricity through transmission lines.
Define feasible. Technically, politically.
I guess technically.
Yeah, technically, yeah.
Would you not lose?
You'd lose some, but you could design your system with kind of high voltage DC lines where it could get there. And I mean, but building it actually, I mean, that's where we run into trouble. So now I'll go through any other questions I should add to the queue as we, okay, I think we're good. So the offshore piece. I met somebody who worked at Dong Energy, which is the Danish company that has the offshore plants outside of Copenhagen. The issue there is cost. I mean, it costs 2 to 3 times more than building onshore. And one of the real things, I mean, servicing turbines anyway is really expensive. Actually, to bring a truck out and change the mechanicals, just bringing the truck out is $100,000. I mean, you know, this is another issue. You know, how do you design them for less costly control? But if you have something offshore, it's even more expensive. And if the weather is bad, you actually can't work on them. And so that's an issue with just cost, and then cost of building as well as O&M cost, operation and maintenance cost. That said, there are some places like offshore Texas. I know you're going to talk about Cape Wind in a few weeks. Most of the articles in Cape Wind in the newspaper came in the editorial section, and they spent a lot of time talking about, the problems of Cape Wind. So the future, wow, I could be a rich woman if I get this one right. My crystal ball. So production tax credit, as many of you who follow this know, it got renewed again this year, but only for 1 year. Whether it gets renewed again, I think a lot of people are kind of watching and seeing. You saw that big push in fourth quarter 2012 to get yourself hooked up to the grid because everyone thought it was going to expire. But I do think that natural gas prices and the low cost of natural gas is affecting the appetite to build wind, because it's very hard. In the Texas situation that I mentioned before, it was an economic case to build the wind. And natural gas prices were high, wind was comparatively low. Now it's just the opposite. That said, there are systems that are already installed, and how do you get the most out of that value is something that's very different. But it's not only affecting wind. I mean, natural gas prices are affecting the dispatch order of electricity, where now we have, for the first time in the US ever, natural gas dispatching before coal. I mean, this throws the whole order of how we always thought about the system kind of on its head. And so a lot of people are just kind of watching and scratching their head. And one of my colleagues who works at the Tennessee Valley Authority said, people complain about the environmentalists killing coal. Natural gas is killing coal. So it's not only wind it's affecting the whole system in very different ways, and I think it's absolutely fascinating. What it means for investments, what it means for our appetite for renewables, for energy efficiency, for any improvement to the grid, I think is a little bit trickier. Because no one wants to invest if your cost curve is hollowed out and you're not earning any money. Turbine repair. So wind in a lot of the states that we examined was often sold as an economic development boost. Right, this idea that if we have more wind, we'll have more jobs, and more jobs in rural areas, which are some of the most depressed parts of our country. And so a lot of the community colleges actually have kind of programs that can train you to work on turbines. And in parts of the country, this is really pretty well developed. And it's like a 2-year certificate program, I think, that most people can get. I don't know, I haven't heard about shortages. There were some wind kind of production facilities where they were producing turbines that they've just closed down, in part because they saw this future supply kind of dropping in the US. So that's another piece of it too. So, I think I told you, but my favorite part in this right now is working with these control system engineers and the electrical engineers and people who are thinking about how do you make your wind farm behave differently? How do we make it behave differently on the grid? I mean, even with what we have, we actually can optimize and make these things work in different ways. So I think it's a pretty exciting time to work in this. And with that, I'd like to thank you all for your attention and your time.